Hello and welcome to today's European SharePoint Office 365 and Azure Community webinar. My name is Shane and I'm delighted to be joined by Scott Dorrow, MVP Solution Architect at Develop One Limited in Canada, who will be talking to you today about managing Canvas apps as source code. Remember to join the conversation about today's webinar on Twitter. Our Twitter handle is @EuropeanSP and our hashtag is ESPC21. Don't forget to check out the Resource Center. This is updated daily with the latest blogs, ebooks, webinars, and how-to videos. Simply visit SharePointEurope.com and click the content link at the top. ESPC21 Online will take place on the 1st and 2nd of June 2021. To be a part of this event, simply register today for free. We also just announced our keynotes, where full details are available at SharePointEurope.com. After the webinar, we will have a questions and answers session. Type any questions you have in the questions window. Questions will be selected and answered at the end of the presentation. This webinar will be recorded and added to the Resource Center, where you'll be notified by email when it is available. And now I'm going to pass you over to our webinar presenter, Scott Dorrow. Hello, Scott.
Hi, Shane. Thank you very much for that introduction.
I can see your screen, so take it away.
Excellent. Thanks very much. So yes, so I am today going to be talking about Power Apps source code, which was a very exciting blog post announcement by Greg Lindhorst from Microsoft back in January. So it's very new. I've been using it for a while, and certainly in the preview as well. So I just thought I'm going to share some of my experience and how I think it's actually quite a big change for if you are writing Canvas apps and deploying them to your environments, and if you are doing any kind of application lifecycle management. So that's what this session is about. But firstly, a little bit about myself. So my name is Scott Dorrow, and I have been a business applications MVP with Microsoft since 2013, which I've had the very big privilege of seeing the Power Platform grow up over the years and seeing it moving from a very disparate set of tools and technologies like Dynamics CRM and the various different pieces that made that up, and then Power Automate coming along, and then all bringing together as the Power Platform. So it's been a real exciting journey, and I think there's certainly still further steps to go. We were chatting before the session, and a lot of people say that I look kind of familiar, and they can't quite place it. But yeah, I don't know. I'll leave it up to you whether or not you think I look like Bryan Cranston from Breaking Bad. You can refer to me from now on as Mr. White or Heisenberg if you'd like, but just a bit of a funny one. But I've recently moved from the UK over to Canada. So I used to live in Oxford, down in the south of the UK, and I've now lived very close to Vancouver. One of the things I'm really kind of getting used to is just the sheer size of this country. Compared to the UK, it's just humongous, but there's a lot less people. But anyway, if you do live or happen to be on the west coast of Canada, do let me know and we can maybe get in touch. One of the big hashtags I use on Twitter a lot, and if you don't follow me on Twitter, look me up there and you can see all the various things I'm involved with. But one of my hashtags is ProCode No Code Unite, which I started with Sarah Lagerquist last year, and really this is about saying, okay, well, the Power Platform very much is moving in the low code way. You know, that's the big paradigm shift at the moment. Everything should be able to be done in a very Excel formula-like expression. But the great thing about the Power Platform is that we do have this option to put in code. You know, you can get Visual Studio VS Code, Azure services involved if you hit a point where you can't actually deliver something using the low code paradigm. And I think this is what really makes the Power Platform unique and really quite special, is that you have both of these sides, that you can have developers create components and then deploy those, and then they can be consumed in a low code way. And really this session is very much on that theme in the sense that we're talking about how you can manage your Canvas apps in more of a source code way. Because obviously, as I'm sure you probably all know, that you can go into Power Apps Studio and you can start dragging and dropping stuff and making your Excel spreadsheet type formulas and really get some fantastic functionality very quickly. But what you're left with is just as a kind of a closed box in the sense of how it can be managed. And what we're seeing here is we're moving to a place where actually that low code paradigm can also be managed in more of a code way using sort of more standard ALM techniques, so application lifecycle management. This tends to be one of those trigger words that if someone mentions ALM, it's like everyone starts to go to sleep a little bit, because it can be a little bit of a tedious topic. I've got a lot of stuff to show you today, so I'm going to try and keep it a little bit fast-paced, so so you don't end up being like this little duck, very cute duckling here, and falling asleep. But you know, one side of ALM, there is a lot of things around requirements management, managing bugs, configuration control, versioning, all of this good stuff that enables you to really make sure that you can track your software through the various different stages and make sure that you can see how it's changing and, you know, giving release notes and things like that. But also we've got on the other side more of a sort of a technical thing. So automatic build and test, automatic deployments, automating things so that you don't have to kind of do repetitive tasks manually, because obviously if you do something manually, you're going to end up doing something that's ultimately maybe going to be done wrong, you know, because we're all human, we all make mistakes. And so the idea is that you can repeat these tasks automatically. So when I want to deploy to my UAT, I can do that automatically. When I deploy it to production, I can do it automatically. I can see what differences there were in terms of the code since the last time I deployed it to these different environments. And this really starts to kind of level up your game, if you like, and ultimately creates better quality software, so that when you get to your support, when you start to go live and you're talking to users, you generally have a lot better experience, because if someone reports a bug, you can fix that bug a lot quicker, because you've got the confidence to know that if you fix the bug and you test it, you know that it's going to get all the way through into production in a quick, efficient, and repeatable way. I mean, often when you're trying to do things quickly, of course, that's when the problems start to happen. You know, you take shortcuts. Whereas when you've got ALM in there, you don't have to take shortcuts because it's already quick. So I think, you know, if anyone can justify why ALM is important, for me, that's really what it's about. It's about being able to do things quickly and efficient without introducing more problems than perhaps the things that you're trying to fix at the time. So there are some kind of overarching principles of ALM that I kind of live by, really. And one of them is everything as code. This is a very important concept, because if you are going to manage your deployment in this ALM kind of fashion, so if I'm going to fix a bug, which is the example I just gave, you want to make sure that you can see the changes that you've made. Okay, so I commit a change and I can see that, okay, well, I've changed lines 5, 6, and 7, and that's the only change that's being made, and okay, we're going to push that into production. So you've got that confidence, you know that the only change you're pushing, and you know because it's repeatable, it's going to get there. It's a great situation to be in, and which of course is very easy for like C# and TypeScript and things like that. Metadata starts to get a bit harder. So if I change a attribute or add an attribute to a table in Dataverse, or if I change a view or something like that, again, metadata, we want to be able to see that that's the only change I've made. And so I can actually see that change visually as code. And when I talk about everything as code, I suppose it's not really necessarily everything as code. It's more like everything as text. So I can diff, I can see the before and the after. That's the really important thing. So data as well, actually. I mean, again, I want to see if I've got some configuration data that's part of my deployment. I want to see that data as a before and after, everything as text. So your data wants to be in source control and see, okay, well, this is what my configuration data was, and now I've fixed an issue or I've added a new feature that requires a little bit extra data, and I can see that clearly in my text. But indeed, anything to do with deployment, like scripts and solutions and flows and Canvas apps and infrastructure, all of the kind of everything that we have part of our real estate that we're moving through the different environments should be at that text readable level. So from a pipeline perspective, you can then say, okay, well, right, when we commit something, you can then grab all of those artifacts, and you can start to version them automatically. You can test them, you can build them, pack them together, run things like the Power Apps checker, the solution checker, and then collect them together and create that as an artifact that you have effectively a deployable artifact, and that becomes your release. And so by having everything as code, it means that when you talk about a build, it really does contain everything that you need in order to deploy it. It's a lot of the time it's very tempting to start to introduce manual steps, and I think one of the things about ALM is manual steps can be the thin end of the wedge. As soon as you have a few manual steps, they generally start to sort of gather other manual steps, and then you start to get those lists of release notes that step 1 do this, step 2 do this, and that's where you ultimately going to run into maybe some inconsistencies and things like that. So having a set of drop artifacts, which is all of those things, that everything as code all together, and then allows you to say, okay, that's our build, which contains everything. We can now move it to all the different environments that we have. So that's kind of ALM in a nutshell. And obviously I could spend a number of hours and boring you, and you definitely would be like that little duckling and start snoozing. But there are a few things that you want to get right from the start. So before we look at the Power Apps source code, one of the key driving principles is treating your environments as cattle and not pets. I had a blog post about this recently, and you'll see why this is important when we look at this, when we look at how the Power Apps source code works. But this allows us to do kind of lots of things like refreshing, resyncing, deleting and recreating our environments. And the only environment really that we don't want to do that is our production environment. So not actually having this kind of environment where you've got lots of things configured manually, and if you delete it, then it's a big problem because you've got to spend all this time to go and reconfigure your environment manually, add the right data. If that's the case, if someone says, oh, I'm going to delete one of your environments tomorrow, and you say, oh, you can't do that, that probably means that you perhaps need to do some work in this area. Another one is a branching strategy, because when you are looking at deploying automatically, and there's this cute little, I think it's a Pomeranian, I think, fluff ball, just kind of moving through the gate there. I mean, how many times have you accidentally deployed something that you didn't want to into an environment just because it was being created? Maybe it was like an attribute you created on one of your tables, or a form that had been created just for a test, and it was just there in your solution, and it's kind of made its way into the different environments. I know that this has happened to me a lot of times, but what branching does is allows you to have parallel development. So you can make sure that when you work on something, you work in a parallel branch, parallel environments, and you can then ring fence that stuff, and you don't have to deploy it. If you have everything in the same environment, of course, what's going to happen is if you want to make a deployment, especially a hotfix or something like that, well, you actually have to deploy everything that you've edited, including these kind of in progress things. And so you can have this sort of experimental branches, but then what you can use is you can merge between those branches, and that's what we're going to start looking at, and using pull requests. And this is teeing up, if you like, really what we're talking about with the Power Apps solution, Power Apps source code. So a branching strategy, there is a fantastic set of documentation called Gitflow. So if you're interested in sort of approaches to how you manage this parallel sets of work, then head over to Gitflow, the documentation, because it describes a whole ton of different scenarios. Really great. But the thing about Gitflow is it's talking very, very much specifically about just source code. So in the software world, really source code, that's everything. Maybe it's a bit of data as well, but ultimately the source code that you for your software is what is your single point of truth. That really is the thing that everyone refers back to. So of course, when you create a branch in your source code control, Git or whatever, you are describing that separate branch is fully describing the software. So it all works very well. The challenge is with the Power Platform is because you've got this environment side of things. You've got your code, you've got your branch, and even if you have everything as code and you've extracted everything into source code, your metadata, etc., you've still got your environment. So I could be making a change to my environment, and say, maybe I want to do a hotfix, and I could make a change to that environment. And if I've only got a single environment, then the next time I want to do a release, then that change is going to happen. It's going to be deployed as part of that solution. Whereas by branching our environments allows us to make a hotfix of, say, for example, in a separate branch and a separate environment. And then when I'm ready, I can then merge that back into my main branch and my main build environment. So starting to create an environment per branch is a very effective way of allowing this kind of parallel development to avoid the Pomeranian syndrome. I think I may have just coined a new phrase, Pomeranian syndrome. But so, I mean, it not only works for hotfixes, right? Because you can have a development branch for sort of like the next version of your software, your next version of your solution. So this could be happening completely parallel to hotfixes. You know, I could be editing, creating an additional feature, and then when I'm ready, I can then merge that into my main development branch and my environment. And then I can bring any hotfixes in and merge those from my main branch and resolve if we've changed, if the hotfix by example has changed the same artifact that I've changed in my feature, so we can resolve any conflicts there. And so this kind of way of working is very, very commonplace in just pure software, whereas it's been a little bit elusive in the Power Platform world. But the first principle definitely is, if you treat your branches and your environments as effectively one and the same, it starts to enable you to do the same things that you can do inside the kind of pure software world. So the thing is, it does introduce a little bit of a challenge in the sense that you do start to get a lot of environments potentially. And the Power Platform, certainly in Dataverse, the change to the storage model has helped a little bit here. So rather than paying for environments, you pay for storage, but still does have a price tag if you do have a lot of environments, because obviously you are going to have a larger storage. But I think this comes down to the benefit of ALM. So you kind of offset that cost against the benefits of being able to do hotfixes in parallel to feature work development and be able to have repeatable deployment. So it does potentially have a price tag in terms of paying for storage, but I certainly feel as though that it does actually fit with the cost. So what's the problem then? So, you know, we spent the last for sort of 10 minutes talking about, okay, well, ALM and this branching, and that all sounds great, you know, everything is code. So what's the problem here? You know, because there are already ways of extracting the solution out, using the solution packager into code, and get a load of XML, and we're going to look at that in a second. But the key problem, which was put a bit of the elephant in the room, was that the MS app files, so the files that are the Canvas app. So if you open up Canvas App Studio and you press F12, or you go to save to your local file, then you get an MS app file, and it's effectively like a zip file which contains all of the bits. But the problem is that if you were in source code and you check that all into source code control, you get this MS app in your source code repository. But if you're looking at the difference between two versions, so I've got a hotfix to that app and I've got a new feature development that I want to merge together, then actually you can't, because it's just this big binary zip file. So this is the fundamental problem. Now, there were some kind of ways around this. You could unzip it, but even if you unzipped it, you did end up getting a whole ton of files that change just randomly, and these were referred to as noisy diffs, things that basically showed up as a change even though there was no change. So it was very difficult to know, okay, if you wanted to answer the question, what changes am I deploying into my environment, it was very difficult to do that. You know, you had to go through a whole ton of data, of files, and most of them were incomprehensible, really, from a human readability standpoint. So this is where this Power Apps Solution Packager, that's what it says, PASOPA, so PA-SOPA. It sounds like some kind of very tasty dish that you'd have for dinner, but this is really the answer to this. And this is what Greg, that blog post I showed you from Greg, is really announcing. And so what this enables to do is to take our solution, our Dataverse solution, all the entities and the model-driven app, and all of the other things that you've got normally, and they would always normally be exported out into source code. Remember, everything is code using Solution Packager. So that's been around for a very, very long time. You know, I've been using it for years and years and years, really to a really good effect. And that creates all these different files that are your metadata about your solution. So your entities, your views, tables, and then they're still called entities in the Solution Packager. All of your model-driven apps, all your flows, your attributes, workflows, everything is all now stored in that human readable, everything is code way. But the Canvas app, which was always this bit of a problem, this is where the Power Apps Solution Packager solves, because what it does, it takes that MS app file and it unpacks it into something that's much more human readable. It's like a set of files which are the Power Apps. It's the Power Apps source code. It's the source code for your app. And eventually, that's, rather than being a separate tool, it's actually going to be rolled into the Solution Packager or the Power Apps CLI. So eventually, at the moment, you know, it's separate, but eventually it's going to be part of the same kind of tooling. And this is kind of coincided with this whole Microsoft Power FX thing, because I don't know if you've seen it, but at Ignite, there was this big announcement about Power FX, which is effectively giving a name to this expression language that we've had in Canvas app for a long time. So usually referred to as the Canvas apps expression language, you know, or the Excel style expressions. You know, these are sort of terms but now it's called Power FX, and what Microsoft is saying is that they're going to make it actually a standard language, actually a language that is in a similar sort of sense to something like TypeScript as well, and it's open source so other people can use it. And that was, again, Greg made an announcement, and if you go to the GitHub repository, it describes, there's a lot of docs there, but this GitHub repository is going to grow, so there's going to be a lot of stuff there around the actual code to create like parsers and things like that for it. But one of the things it mentions is that it's this YAML formula grammar. So unlike the expression language you just get inside Canvas apps, obviously you're just writing it. If we're going to represent this as a Canvas app in a human readable way, we need some way of taking a Canvas app and actually showing all of the properties of our buttons and things like that alongside these expressions. And what Microsoft have done is they've chosen YAML, which is it stands for yet another markup language, but a lot of people really don't like it because it's very a bit of a joke here. Actually, this is it's kind of a very indentated version of your source code. And I'll kind of show you how this looks. So let's just dive over and crack open Visual Studio Code. And what I've got here is I've got the Power Apps Solution Packager XE, which you have to build at the moment from the source code in GitHub. So I've already built it, and if you go to the GitHub repository, there's instructions like a build script and things like that. And I've also got actually got a app, which is this kind of very straightforward. You know, I've got 2 screens. I've got create tasks from template screens, so you can create different sets of templates, and then I can go and edit my individual app. So, you know, and create new ones. A very similar sort of scenario to building apps. So what I can use Power Apps SOPA. If I just do that, it gives me the different options. So I can unpack and I can pack and make. So this is the fundamental way to work. So if I do unpack, and what I'm going to do is I've actually extracted, so you can see here, my tasks my tasks MS app. So this is the actual app that I've just saved directly out of Power Apps Studio. So I'm going to do my tasks MS app, and what we do there is very simply run this, and what it does is it extracts it, unpacks it into this kind of folder structure. So there's a lot of stuff in here, like connections about, gives us the connections I have to CDS in this case, or Dataverse. So I've got it describes my tasks data set that I'm linked to, and the schema. So that's all very good. But the really exciting stuff is down here underneath the source area, because what the source does is it actually gives us each screen as a source code, as a human readable version of that screen, and it's a YAML file, and it also gives us a YAML file for the app as well. So this is the overall app, like if you've got an app on start, event, those kind of things. So if we open up like the task screen, what you can see here is you can see a sort of a very declarative way of describing my app. So I've got, okay, my tasks as a screen, and then I've got the the fill color and things, and then I've got a label, title 1, next arrow, separator, all the kind of stuff, and then I've got a form on it and all the different things, the data cards, and you can see all the different properties. So if you're used to writing Canvas app, this should all look very, very familiar. And what you can see is that there are some expressions. So you can see here that there is a, this is a Power Apps expression, but now this is effectively, this whole file is now just basically called Power Effects. So we've got these Power Effects style formulas embedded inside YAML. And what this means is that if I make a change to my app, then I can quickly see those diffs. And I'm going to show you how that works in an ALM sense. But what I can also do is, say, for example, I wanted to make a change to something. So I don't know. Let's take a button here. So if I wanted to make a change, so say to just a very simple one, to change the text. Obviously, I could make a change to any of these things, or indeed I could even start adding new buttons. But I'm just going to save that, and then I'm going to use the Power Apps SOPA to say pack. And what this asks for is the app that I want to pack into, and then the path to the source code. So I'm going to call this my tasks 2, and put it as MS app. And then it wants the location of the source code. So I'm going to copy the relative path to that, put it that. So when I run that, it will now pack them together. And so I've now got my tasks 2 there. So what I'm going to do is copy the path of that. I'm going to go into Power Apps here. And I'm going to go and open up Power Apps. Let's just edit this Power App here, and because I've made a change, I can easily just load up that MS app file into my my App Studio and carry on editing it. So at the basic level, the Power App SOPA unpacks to a set of source code, everything as source code, allows this a very human readable way of working, and then what I can do is then I can make a change, or indeed there's other options. I could say, for example, go and add in some functionality that's perhaps based on a data schema, sort of like code generation, something like that. So it opens up a whole ton of options. So I'm going to open up this my tasks 2. There we go. And this is, remember, this my task 2 is completely generated from the source code. There was no sort of other connection to Dataverse that it had, no connection to Power Apps, just simply had a whole load of files, and it packed it together. And you can see here that the label has changed in terms of the Save Task button. So that's really how it functions at the base level. So what's the big deal then, really? Because obviously ALM is I think the primary focus. You can do other things like search and replace. So if, for example, suddenly we don't talk about tasks anymore, we talk about activities. Well, I could do a search and replace and change all of the instances of tasks and change them to be activities. Obviously, being careful what you did in the search and replace. You could update if you knew exactly what you need to make a change of. You could actually make that change directly in source control and change the formula as you wanted to, and then deploy that, and then you know that formula has been changed. You could also, if you wanted to, because there was a make option, I could also create a Power Apps directly from source code. But I'm not sure that actually source code editing like that really is where we're at the moment, because obviously, as I mentioned, code generation from schema and metadata. To me, these are all interesting alternatives, but not particularly practical from a practical standpoint. Certainly, I'm doing some experiments and seeing how it works to see how that goes. And if you follow me on Twitter, I'll kind of let you know how that goes. But what I want to show you is, to take a little bit of a gear shift and show you how this all works inside an ALM, because ALM is one of those bit of the emperor's new clothes kind of situation. There's a lot of people talk about it, but it's sometimes hard to actually see how people are doing it in real life. So I've got a very simple idea. It's a very simple situation here where we've got two branches. We've got the we've got our feature branch here for the editing tasks. So this is, remember, we had two different screens. We had an edit screen and we had another screen which was for creating a scheduled set of tasks from a template. And the idea being here is that we are making changes in parallel. So I've got two teams, potentially two development teams, and one are working on the edit task screen and one team is working on the scheduler screen. And the scenario here is that the first team makes some changes, but in parallel, the second team are making changes to the same app. Now, at the moment, that's, if you didn't using this tool, this would be impossible. You'd have to manually kind of bring them together. But what this enables, because everything is in source code, this pull request, and I'm going to show you how this works, the pull request will then allow us to bring in the changes from the first team into the branch that the second team are working on. So they might say, well, the second team's right, well, we're ready for your changes now. And then after you've resolved any conflicts, and hopefully there won't be any, and this is no different to normal code, right? If we're writing TypeScript or C#, this is not a normal situation. I could be editing one of the TypeScript files, and someone else could be on a separate branch. When we bring them in, we find they've made some changes that are actually going to have to be resolved and worked out how to merge those two together. So it's no difference, and that's the point. We're treating Canvas apps no different to normal code, and that ultimately is the end game of all of this. So any of the problems you have with branching are common problems that are happening in software development. And then you could make some further changes, and then we can merge that into our dev and then release it. And that can all be done through automation. So deep breath, and I'm going to take a quick swig of my drink. It's just juice, so there's nothing stronger in there. It's but there's a lot to cover. So this is I'm using screenshots because to do this, actually show you the demo. I mean, actually, I recorded this yesterday and took screenshots. But to do it actually end to end takes quite a long time, more time we actually got because of all the pipelines that run. But what we're using is we're using Azure DevOps. And we're using pipelines inside Azure DevOps and release pipelines, build pipelines and release pipelines. If you wanted to do, a lot of this functionality is now available in inside GitHub as well. But we're using the Power Platform build tools to do a lot of this, as well as this new tool, Power Apps Solution Packager. So we've got two branches. We've got our first teams branch. You can see we've got our master and our dev and our first teams branch. And then we've got our second teams branch in parallel. So kind of standard stuff. But what we've also got is we've got some pipelines here. So we've got our continuous integration build, and that's the kind of common build pipeline that you'd have in any software ALMs, where it checks everything out from source code, builds it, creates a deployment artifact ready to be deployed to the different environments. But then we got these two additional ones. So deploy branch to environment allows, because I've created a software branch, I created a branch in code, and so remember I was talking about environments and branches, kind of you thinking about them as the same thing. Well, of course, I've created this branch in my source control. What I need to do is actually deploy that to a particular environment, and so that this pipeline will actually do that. So when I run that, I can run that both on branch 1 for the team 1 and branch 2. And so what that does is it goes and takes it gets the code out of source code, it builds it. So any TypeScript or C# or anything like that builds. But then it uses Solution Packager as well as this new Power Apps Solution Packager and packs it. And then that creates a solution file, a solution zip, and then it imports it into the branch environment as an unmanaged solution. And then of course it publishes it. So this is really kind of important, because this allows us to join the two things together, that in branch and in environment. And once we've got that, we can now have these two teams starting to work independently. So I can have, say for example, the second team. They might say, okay, well I'm going to go and edit the solution, and I'm going to go and edit my tasks app, and I'm going to make a change, say for example change an expression here where I'm changing the display mode expression on a button. The kind of really depends on what kind of work's been going on, or they might go make an expression, a fill conditional expression. This just highlights the row that's currently selected. I also might go over to the scheduler screen. I'm making changes to two different screens here, and make some changes to add. In this case, I'm just adding an additional item to a collection. So basic stuff, which you would normally do, and that's no different today. And then we'd publish that. But then what we do is we use this second pipeline called feature unpack, and this is effectively the reverse. Okay, so before we said deploy branch to environment, that was taking the code from source code and putting it into an environment. What this is doing is this is actually taking it from the environment and putting it back into code. Okay, so when we run that pipeline, obviously it would take a long time to run. When it's not a long time, it takes about 5 minutes, depending on obviously the performance of the environment. And what that's doing is it's exporting the solution from the environment, which will obviously include your Power Apps Canvas app, as well as any other entities, etc. And then it uses the solution packager to unpackage it, but it also now uses this Power Apps solution packager to unpack, and then commits it into source code. And this is really where it starts to get cool, because what we've got now is you can start to see, if you remember, I was talking about having this kind of human readable differences, and you can see here that these are the actual diffs that I've made to my Power App. Okay, because remember when we used the Power App Solution Packager at the command line just a minute ago? Well, what we have now is we have those source files in source control. Excuse me. And so what you've got there is you've got your task screen and your scheduler screen, and they're showing up as a change. And each of those changes is highlighted in source control. So if I was going to say, okay, well, what changes have you made, and asking team 1, because I want to take your changes, team 1, into team 2's branch. Suddenly, I can clearly see the changes that have been made, and I could even, if I wanted to, cherry pick. So I could say, I don't want this change, but I want another change, and because it's exactly the same as if you were doing it in source control. So meanwhile, on the first branch, they may say, okay, well, I'm going to go and add an attribute to a table, to add a field to a table, and I'm going to go and add that to a view. All kind of basic Dataverse kind of stuff. But I also might edit my app as well. So I might rename a button, change the filter that's used on a gallery, and then save and publish it. Again, normal stuff. But again, I would run my feature unpack to take that solution, take those changes from the Dataverse environment into source control. And what that does is introduces, because it's checking in, it actually adds a change set to my branch. And again, I start to see these are all the differences of my source code. And I can see exactly what I've changed. And if I had any unintentional changes, they would again show up here. But as well as the Power Apps Solution Packager, of course, alongside that, we made a change. We added a field in Dataverse and added it to a view, because we also using the standard solution packager, which eventually it's going to make its way into. We also see all of the kind of standard stuff, like the changed. I added an attribute, so you can see that in the code. I added an attribute to a view, and again, you can see that inside the XML files. So that's the standard solution package stuff, which we've had for a long time. So what we're seeing is the Power App Solution Packager is effectively allowing us to do exactly the same as we've been doing for a long time with the normal solution packager for the rest of the Dataverse, in the same sense. But of course, now what we've got is we've got two parallel changes. I've made all these changes for Team 1, and Team 2's also made changes. And now Team 2 wants to actually take Team 1's changes, so they want to get that into the next release. Well, what we can do here is we can get a pull request to move from Team 1's branch into Team 2's branch. So I'd go into my Azure DevOps and create a pull request. And this is where it gets interesting, because that pull request is saying, what's happened is that Team 1 have made some changes to the same files that Team 2 has made changes to. And so what the pull request does, it tells you what conflicts there are, because you want to merge the file, but you can't merge if two sides have made this changes to the same files. But if you notice, what it doesn't show here is it doesn't show the YAML, because it's only showing files that it can't work out how to merge automatically. Because Git merges are actually pretty clever they have they do understand code to a certain degree, and they can work out where there are additions and changes to codes when you're merging it. So both teams made changes to the task screen, and we can actually automatically merge those. These files actually are all kind of artifacts of the solution packager that really don't make any difference. And in fact, what we can do is we can just simply ignore these changes. I can just simply select keep all target files, because as long as it's to do with the entropy and the checksum and any metadata about the app, I can effectively ignore them. If there was a merge conflict at the YAML screen level, that's where it would become more important. So obviously we'd need to look at, well, actually maybe I've made a change to the same formula in two different places, and then that would show up as a merge conflict. But I can then see exactly what code is on both sides and make a decision there. So once I've made that merge, now what I've got is I've got the changes from Team 1 in Team 2's branches. So that where I changed to select a different view, that was made by Team 1, but I'm looking at Team 2's changes, and equally when I renamed the button. And when we complete this change request, we've obviously got the XML as well from added the field and into the view. When we complete that, it pushes all of those and merges all of those changes into the Team 2's branch. So now what I can do is I can run the deploy from branch to environment to actually move that into Team 2's environment. Because remember, I've got the changes in Team 2's code in that branch, but I haven't got them in my environment yet. So when I run the deploy to environment, it will then check out the code, build it, pack it into a solution, and then push it into that environment. So now we've got both Team 1's and Team 2's changes in Team 2's environment. So we can see that by opening up their environment, and there's the new attribute, and we can open up the app. I can see the change I've made to the views, it's all there. But also equally, I get the changes that had been made by Team 2 as well. So we've got Team 1 and Team 2's changes in the same environment, all merged at the Power Apps level. And this is pretty amazing, because we literally, you would, to do this before, without this tool, you would have had to do this manually. You'd have had to ask for a list of changes and then manually gone into Studio, Power Apps Studio, and made those changes. And of course, what's ALM about? ALM is about repeatability and about accuracy and removing the human error element. And that's exactly what we're doing here. And then the last thing to do, obviously, is to take that, create a pull request, and merge it into our main dev branch so we can release it. So the pull request, we would merge. We're asking here to merge from the Team 2's branch into dev. Of course, you can see all the changes, and this is really, really cool because I know that, okay, this is the only changes I'm going to be releasing. So no Pomeranian syndrome, and so what we're doing is we complete that pull request. It gets merged into the dev branch, and of course, our continuous integration build is automatically running on the dev branch, and so it kicks off. And what that would do is it would check out all of the data, all of the code, build any TypeScript, C#, get all the solution XML and the Power Apps source code as well, version it, build it, pack it together, import it into a build environment, because at the moment it's unmanaged. So we want to import it into a build environment to then convert it. So we can export it from our build environment as a managed solution. I'm not going to get into managed versus unmanaged, but this is generally accepted as the best practice at the moment. So once we've got an export of managed solution, we then got a drop artifact, and that drop artifact can then be deployed to all the different downstream systems. And so there is a whole ton of documentation, and there's a really great labs from Microsoft, or the ALM labs, that kind of show you how to do this stuff using the build tools inside Azure DevOps. And generally it works pretty well. And so this downstream from our merges, the deployments just work as they would do normally, and you've got a managed solution that you can use as your deployment artifact. So then, using a release pipeline, I can go and create a release, and I can select that latest build and deploy it to QA or whatever environments that I'm going to be using. So it's pretty awesome to be able to manage your Canvas apps in the same way as managing it was TypeScript or C# or my solution XML from my solution packager. One of the things that is being a problem a lot over the years with a solution packager, and I mentioned earlier, is something called noisy diffs. So noisy diffs is basically where you would see a change in your source control that is not directly related to a change that someone has made intentionally. And what it means is it's your signal to noise ratio. It kind of dilutes the changes that you're actually making with all these other changes. And so it's very difficult to say, okay, well, what changes are we actually deploying? Because then you see a whole load of noisy stuff and all clouding the actual real changes. But what I love about the YAML and this Power Apps solution packager is that they are really good quality diffs, and that's been one of their main priorities in developing this, is to make sure that there's only showing a diff, with the exception of the entropy and the editor state files. Because remember, when we did the pull request, there was those conflicts with because those can be deleted or ignored. Literally, they're not required to build. They're much more required to preserve the editor state, which screen you're currently on, and those kind of things. And so those can be deleted. So with the exception of the entropy and the editor state, the actual quality of the diffs that you get out of the screen YAMLs is fantastic. You only see the changes that you've made. So if I go and edit button, move a button, change a button's color, change the expression on select a button, that's the only change that I get. So you can see exactly what change you're making. So when somebody asks you, are you sure that that's the only change you've made when you're deploying that next app? You can say with confidence, definitely, that's the only change that I've made, because you can see clearly in your pull request that those are the only changes you've made. Entropy, editor state, those can be all safely ignored. And in fact, potentially not even checked into source code. I'm not entirely sure what the best practice is here, but at the moment, I effectively just ignore them from my pull requests. So covered a lot there. So lastly, I just want to kind of go through some quick tips that I found using this. Don't go crazy with the merges, because one of the things that you could do is make a lot of changes, a whole ton of changes, very structural changes to an app in parallel to someone else making a whole ton of structural changes. And of course, it's exactly the same as if I was doing this with normal source code. If I made structural changes to a TypeScript or C# app and wanted to kind of merge those two together, that's going to cause problems. So don't go crazy with the merge. Be cognizant of the changes that are happening in parallel. And if you can at all possible, make sure that when you're parallel working on things, if you can isolate it down to as different screens or different aspects of an app, so team 1 knows that team 2 are working on a different part of an app, so that you're aware of what's going on at the same time. That's going to make it easier to merge things, because if you create a pull request and you've made really big structural changes, it is going to make it very time consuming to go and look at all the different changes to make sure that you're comfortable with the edits. You will be able to understand them because they're human readable. That's the point. But the more changes that are made, the harder it is to do that process and more time consuming. And so what I like to do is to say, let's keep the changes as feature tight as possible. So we're making a very specific change to a specific purpose, so that when it comes to the pull request, you can clearly see where the changes have been made. This was a really simple one, and it's caught me out a number of times. If you're running that pipeline to package and import into an environment using the Power Apps build tools for Azure DevOps or GitHub, if you leave your Canvas App Studio open on a particular app, it's effectively locking it out. And so you'll need to make sure that people close it, otherwise you won't be able to sync your environments. A lot of the times with MS Apps, people will just use the export app, import app tool. Well, in order to really get the best out of this functionality, use solutions, because solutions allow you to manage your versioning of a whole load of different artifacts all together. So Dataverse tables, apps, multiple apps together as well, working in tandem. And then it also makes it easier to then manage a single deployment artifact when you're looking at merging the different branches together. I mean, if you wanted to, I guess you could create a single repository for a single app, but of course, if you grow up and start adding more different apps, then it's going to make it harder to manage. Always name your components inside your apps consistently, because when that merge happens, it's clever enough to sort of understand that, okay, you've got two buttons here. One's button save and one's button delete. So if you've moved those two buttons in the Z order, move them around one above the other, it's pretty clever in the sense of it can see what's going on there. So don't just name your buttons 1, 2, and 3, because if someone adds another button called button 2, then it's going to get confused of where it is in terms of the app. So giving unique names makes those mergers a lot easier. And then also one of the things that I found is when you're unpacking apps, the region and the Power Apps version that you're using, the Canvas App Studio version, actually has a bearing on what you get unpacked. So if you're going to be merging and having parallel teams working, make sure that they're all on the same version and the same region as well. So you'll get consistent unpacks. So it makes the merging a lot easier. And then pull requests, as I showed, are a fantastic way of keeping track of what you are going to do. And in fact, even when you've created the branch, as soon as you know that there's going to be a merge, create the pull request. Don't wait to create the pull request last of all, because what a pull request does is actually, every time you run that unpack pipeline and you get it into source control, you'll be able to go there and use it as a reference point to see the changes that you've made. And you can even have, if you wanted to, the unpack pipeline running on a schedule, running every day, running twice a day if you wanted to. And so you've always got a reference point to see what changes you've made relative to another branch that's currently been working on. And then Lastly, always have your environment strategy to hand. Maybe draw a picture, put it on the wall, whatever, because understanding what's happening in the different environments and what branches they're linked to is paramount to enable you to really understand what work makes sense to be merged into where, based on where it's going. If you know that you're going to have the next release of your software, it needs to include these 3 different features, and they're all being worked on different branches, just draw a picture and see how it makes the most sense to merge, especially when you start to looking at testing them all together, integrating them. So my last point is that it is still experimental. So as I said at the beginning, the Power Apps solution packager at the moment is a separate tool, and it will be included eventually in the standard Power Apps build tools. But at the moment, you kind of have to have it as a separate, you have to actually build the code yourself from GitHub and run it that way. So it is experimental. So this is sort of early days in that cycle of ALM. So if you're not already doing ALM for using the solution packager, I'd highly encourage you to start doing that for all your Dataverse tables and columns and views and dashboards and model-driven apps. Get that in place so that when the solution packager for Power Apps comes on, you'll then benefit from all the diffs from your Canvas apps as well. But it's certainly really it's certainly really exciting because it introduces so much more visibility, and I mean, you can use it today. It's just that you have to run it separately to the solution packager. So that's me. That's been a quite a lot to take in. I appreciate, and this session has really been very much an art of the possible kind of session. It's I haven't gone right down into the weeds of how you write the pipelines and all of those kind of things. But hopefully what it's done is it's given you a little bit of insight into how you can benefit from this new tool alongside your existing ALM strategy, or indeed maybe it's inspired you. If you don't already have an ALM strategy, it's inspired you to start to sort of move towards this parallel branching. But there's 2 links here. One is the link to the GitHub repository, which has got the Power Apps solution packager code there and instructions on how to build it if you want to take it for a test drive. And then there's also the PowerFX GitHub repository, which is the new announcements, where that's where all the docs are about describing how Canvas app expression is actually now PowerFX, and how it can be represented either just in a YAML document or in another code file. So some further reading. But yeah, if there's any questions, we can take them now.
Thanks for a great presentation, Scott. Yes, now we will start the questions and answers part, and should you wish to ask Scott a question, please type it into the questions window now. Okay, Scott, there is one question in there so far. I don't know if you can see it. It's, would you recommend deploying managed or unmanaged solutions? How do you handle environment variables, connections like SharePoint URLs for dev, UAT, production?
Yeah, so it's like goading me into the managed vs unmanaged discussion. I mean, I personally recommend managed, and I think that's really the only way you can go down, because that is the advice from Microsoft. So the Microsoft Power Platform team strongly say that if you're going to deploy to a downstream environment that's not development, use a managed solutions, and I've certainly been using them, for a couple of years now successfully. Prior to that, there were some problems, and so I used to be much more towards, unless I was creating an ISV product or something that was being deployed to many different customers, then I would have been unmanaged. But these days, managed is definitely the recommendation there. So how do you handle environment variables? So environment variables are actually part of the solution packager. So if you use solutionpackager.exe or use the Power Platform tools for Azure DevOps or GitHub, when you unpack your solution, they come down as XML, and you see them there as a and obviously what you would do is you tend to set the default value in your solution to be the kind of the target values, and then it means if in other environments you can override those values. And so yeah, that's again, everything is code. making sure that your solution packager contains not only the actual solution XML, but any other scripts that are needed. So if you are setting particular values, then having using PowerShell or something like that, actually having those scripts in your environment. And what I tend to do is have switches in my pipeline to say, okay, if it's being deployed to this pipeline, then I run this script. Sorry, run this environment, run this script. If it's this environment, run this script. Those kind of things. So yeah, SharePoint URLs is a classic situation for that.
Okay, next question. Is the solution package idea similar with how solutions managed or unmanaged work in Microsoft Dynamics?
Yes, basically it's the same, exactly the same idea. So when I was talking about the solution packager.exe, that is the same solution packager that came from the Microsoft Dynamics world. And my understanding is that the Power Apps solution packager will effectively be rolled into the old Dynamics, because when you're using the Power Apps, the Power Platform build tools in Azure DevOps, that is running actually the solution packager that came from Dynamics. It is one on the same thing. And this is, as I alluded to before, the journey that's happened is really come from a lot of this technology that came from the Microsoft Dynamics world is now all Power Platform stuff. It's exactly the same tech. So someone wants me to go back to the
and then back to the tip screen. Yeah, they just want to do a screen grab. So hopefully that person there. This session is being recorded, and you will be sent a link, by the way, to this either today or tomorrow. Okay, super. Hopefully there's enough time there to make that screen grab. Okay, brilliant. Brian, on behalf of the Brian, what am I thinking? I've got
just call me Heidelberg, it's fine.
I've got Brian Cranston on my brain. Okay, sorry. I'm on behalf of the ESPC community, Scott. Thank you for taking the time to complete this webinar. We really appreciate it. God. Starstruck. I'm just not used to being in the presence of Hollywood stars. That's all.
It's been great to thank you very much for having me. It's a topic that's really close to my heart, and yeah, if anyone's got any questions and you want to have a kind of philosophical discussion about things, then please do reach out to me.
Brilliant. Well, thank you everybody for joining us today. Don't forget, ESPC 21 online will take place on the 1st and 2nd of June 2021. To be a part of this event, simply register today for free. We also just announced our keynotes. Full details are at sharepointeurope.com. Thank you all for joining us today, and again, a big thank you to Scott Durrow. This is the end of today's webinar. Thank you all for joining. Take care and goodbye.